Hi, my name is Marc Roussel. I'm a professor of chemistry at the University of Lethbridge in Canada and the author of a new textbook entitled Foundations of Chemical Kinetics, a Hands-on Approach. This textbook is intended for students who've already had a basic introduction to kinetics, who know, for example, what a rate constant is and have seen the Arrhenius law, and maybe have applied the equilibrium and steady state approximations in some simple cases as well. If you've reached this point in your studies, you may be wondering, why do rate constants have the values they have? Why do we sometimes have reactions that seem quite similar but have vastly different values of their rate constants? We have some beautiful theories that address this question, among others. Those theories are the foundations of chemical kinetics referred to in the title of my book. When I took a similar course as a graduate student in the late 1980s, we could talk about the theories and do some very simple pen and paper calculations, but we couldn't really get very far. And the reason for that is that back then, to do the calculations the theory required us to do, needed research level computing, which we just didn't have access to as students. Now, though, your desktop or laptop computer is plenty powerful enough to do the calculations suggested by the theories of chemical kinetics, at least for some smaller systems. And that's the other thing I wanted to do with this book, to let you experience the theories of chemical kinetics hands-on, to actually do the calculations yourself and not just to read results of other people's calculations. Now, to do that, you need to learn some computational chemistry and a little bit of programming. So I included a brief introduction to computational chemistry using Gaussian and Gauss view, as well as an introduction to programming using MATLAB or its free cousin Octave. I'm a strong believer in learning by doing, and that was the whole philosophy behind this book. I hope you will enjoy studying from Foundations of Chemical Kinetics, a hands-on approach.